Right, so today we're going to study area comparison for triangles. Okay. So we have two formulas for the area of triangles, which we're going to use to compare. Okay. The first one is the well-known formula. Okay, so this is a triangle, right? A, B, C. Okay, so the height is H, the base is B. Okay, I have another triangle. This may be a slightly different triangle. Okay, and then the base will be B prime. So the height is still the same height. So they have the same height. So they have the same height. Now, I want to, for the area of this triangle, ABC, right? It's going to be half of the B times H, right? The same is true here. B prime H, so they have the same H. Now, then we compare. When you compare those two areas, okay, I get half of the B times H and half of the B prime times H. So what happens? One half is gone, right? H is gone. So just equal to the ratio of their bases. Okay, the length of the bases. Okay, so this is a pretty interesting formula. Okay. Okay. And so using this formula, we can solve several problems. Okay, one is this one. This is a trapezoid. Right? Trapezoid. Okay, here's A, B, C, D. I know AB equals 3, DC equals 6, for example. Okay. I also know the area of the triangle ABD, the one on the top, is going to be 5. Okay. So we find the area of the triangle at the bottom. So BCD. Okay. So to solve this problem, there are several ways to do. If you use a comparison, it'll be much easier, okay? Because those two triangles have the same height, because this is a trapezoid, okay? Right? This trapezoid is the height for the triangle on the top is the same as the height of the triangle for the triangle at the bottom. So because this is here 6, right? So the area, the comparison ABD and the area of the triangle BCD, this is just the ratio there. They are the lengths of the bases, okay? So that's just equal to 1/2. Now, we also know that the area of the ABD is going to be 5. So what I'm going to do, then I get the area of BCD is going to be 2 times 5, which is 10. So that is So those two triangles, they look quite different, because they're not similar, but they have the same height. Okay, they have the same height. Okay. So another problem I want to discuss is you have a triangle like this. Okay, and this is actually it's going to be equilateral triangle. Okay, so we have, okay, so I have 2, 2, and the 2. Okay, this is it. And this is I draw 3. Okay, so here's A, B, C, D. No, I did not draw. Please. Yeah, let me reschedule. Okay. This is does not look like the one I'm drawing. Yeah, let me redraw it. So first of all, I draw an equatorial triangle. Okay, an equatorial triangle. Okay, 2 and 2 and 2. So A, B, C. Then I extend it. Yeah, 3, D. So yeah, CD is going to be 3. Then I then I connect this. Okay. So CD is a 3. Okay. So AB equals BC equals AC equals 2. We want to find out the area of the triangle ACD. Okay. So you want to find the area of the triangle ACD. Right, you're only given the 2 sides. This is a triangle we're going to find out the area, right? So if you just focus on this triangle, you're not able to solve it. Okay, you need the 3 sides to get to the other sides. AD is a very strange number. Okay. You have to use a computer to find it. But we're still able to find the area of this triangle. How do you do that? Well, so the area of the triangle ABC and these 2 triangles have the same height, ACD, right? These 2 triangles have the same size because there's a shear the vertex A. So there, if you draw the line, vertical line, you get the same height. So therefore, it's going to be the ratio of the base, so the BC over CD, which is 2 over 3, okay? So now, what do you get? You will get the area of the triangle ACD is going to be 3 over 2 times the area of the triangle ABC. But the ABC, you can find it. Okay, equilateral triangle. How do you find the area of equilateral triangle? The equilateral triangle, yeah, I'm going to put it here. So this is an ABC, 2, 2, 2, right? So the equilateral triangle will have a formula, okay, for the area. So the area of equilateral triangle ABC is going to square 3 over 4 times 2 squared, which is square 3. Okay, how do you get that? You can solve this problem using any method. Okay, you can, the quickest way to do is this is a special triangle. Okay, this is when this is side 1, so the other side must be square 3. Okay, why? Because you apply the Pythagorean theory, right? And the other side is square 3, so then you have square 3 times 1 divided by 2, then multiply by 2, so square 3. Okay, yeah, that's easy to figure out. So this is a right triangle, so you can apply the Pythagorean theory. Okay. Yes. So then you solve this problem, right? Then you get to the area of the triangle ACD. ACD, right, is going to be 3 over 2 times square 3. Okay, that. Okay. Now, if I change the problem a little bit, I'm not going to draw equilateral triangle. What I got here is something like that. Okay, so I have 12, 5, 13. Okay, then I extend it. Okay, so this is also 12. Okay, got it? So A, B, C, D. So, okay, clear, right? Yeah. AB equals 5, AC equals 12, and BC equals 13, right? Then CD equals 12. I want to find out the area of this isosceles triangle ACD. All right, so I'm going to ask you to do this problem. All right, I'll give you a couple of minutes to think about. Okay, we have one student give his answer already. So first of all, yeah, let's look at the comparison. Okay, so they have these two triangles have the same area, right? You know, they have the same height. So the triangle ABC over the area of the triangle ACD is going to be 13 over 12. So I can get 12 over 13, right, times the area of the triangle ABC. But the triangle ABC, you know that you can, if it's more arbitrary, you can use a Heron's formula. Otherwise, just double check this identity, right? For 144, 25, then 169. So add them together. This is a right triangle. If it's a right triangle, and this is just half of 5 times 12. Okay, half of 5 times 12. Okay, so so you can get what do you get, right? Yeah, then you multiply them out and you get an answer. Okay, so let's try. Yeah, let's do the simple computation. So you can get, right, 6 times 5 times 12. Yes, 360 over 13. All right. So that is answer. Now, if it's an arbitrary triangle with 3 sides are given, and then you have to use the Heron's formula to get to the area. Okay, so that is this is a very good problem. Now let's look at the more complicated problem. Okay, so we have a triangle here. Oh. My file is gone. Okay, now it's back. Okay. Sorry, somehow I touched the screen. Somewhere it's disappeared. Right. So my next problem I want to discuss is the following. I have a triangle. Oh shit. So we have a trouble with the file. Yeah. Okay. I hope it did not disappear. Otherwise, I have to restart the computer. Okay. So we have the file. Yeah. Let's see. This is a triangle. Okay. And I draw the line, an arbitrary line, and this is A, B, and C. Okay. And this is a D. This is E. Okay. We are given the following information. Okay, the area of ABE is going to be 3 square centimeters. Okay, BDE is 5 square centimeters. We also have the we also have ACE, yeah, this is going to be 6 square centimeters. So we want to find the area of the triangle. Okay, so no sides are given. No sides are given. Okay, so you don't, no sides are given, so you don't know the exact value of any sides of the triangle. So you have 4 triangles here. Okay, and you want to find the area triangle ACE. Okay, think about that. Okay, 3, 5, 6. Okay. Anyone has ideas? Yeah, this is a little bit more complicated than the above one. You have to use 2 pairs of triangles. So first of all, yeah, let's see. This is the area comparison, right? The triangle ACE. I look at the 2 triangles on the right hand side and the CDE. Okay, so the 2 triangles on the right hand side, which is given. This is already know that's going to be 6, right? And that is given. Should be equal to the ratio of these 2 sides. We don't know the exact length, but we don't know even the ratio. But then you look at the 2 triangles on the left. Okay, you look at the 2 triangles on the left. Okay, you look at the 2 triangles on the left, and you still have a similar comparison. The triangle ABE and the area of the triangle BDE. Okay, but we already know that this can be 3 over 5. Okay, so therefore, the area of triangle ACE is going to be 3 over 5 times 6, which is going to be 18 over 5 and the square centimeters. Okay, good job, Erica. Okay, so this time you use 2 pairs of triangles, and the ratio is going to be the ratio of the base, but the base is share. There's 2 pairs of triangles that share the bases. So that's why you don't need to know the exact length of AE, and you don't know the exact length of ED. It's not necessary. Okay. All right. Our next problem is we consider a parallelogram. Okay. I consider parallelogram. I want to show that. Okay, this is A and B and C and D. So I draw the two lines and I intersect with E. Show that all of the four triangles have the same area. Four triangles have the same area. The triangle ABE equals the area of the triangle BCE. Okay, equals the area of the triangle CDE equals the area of the triangle ADE. Okay, so why they all equal? Okay, how do you prove that? The key point is, okay, key point E is the midpoint of the diagonals by the symmetry of the two diagonals by kind of symmetry, right? Okay, kind of symmetry. It's not exact symmetric, but this is yeah, by symmetry in some sense, right? So this is clear. Everybody accepts this, right? Right. So they intersect at the middle point. Right. So once you use this, then you can show why is this two triangles similar. Okay. Why does this triangle have the same area? Okay. Okay. So I just want to prove that the area of the triangle ABE compare with the area of the triangle BCE, right? And this should be equal to AE and EC. But A equal to EC, that's why equal to 1. Okay, then those two triangles are similar, right? And similarly, these two triangles are similar. So you can go around all of them have the same area. Okay, so they are all equal. Okay, by similar argument, they can prove that all the triangles are similar. Okay, so this shows that the triangle ABE equals the area of the triangle BCE. Okay, and by a similar argument, you can prove that they are all equal. Okay, so the idea is just because this is the middle point. Yeah, E is the middle point. So you can compare, you can compare this pair of the triangle, you can compare those two triangles, and then go around, and then they're all equal. Okay. Right, so this is how do we how do we do that? Okay, let me ask you to do the next problem. Okay, we have a triangle like this. Okay, so here's A, B, E, and the C, and the D. And what we are given? We are given the area of the triangle ABC, which is going to be 2. D is the middle point. Okay, and the CE is going to be twice of CD. Okay, I want to find out the area of the triangle BDE. Okay, BDE is this one. This is the extra part. Okay, so we are given the area of this triangle. Okay, and we have to find the area of the triangle in the yellow color. Okay, so please do this problem. So Grant Moore, did you have an answer? That's cool. All right, so good job. So how do you do this? We use a comparison theorem, right? We use a comparison theorem. We just needed to know. The area of the triangle BDE, right? Compare with the area of the triangle BCD, right? So those two triangles compare. And that's supposed to be CE over CD. So CE over CD is going to be 2. So there's this here one, double it, okay? But the question is, what is the area of the triangle at the bottom, right? So this is right? So then you get the area of triangle BDE is twice of the area of triangle BCD. But BCD is half of the whole area, right? Yeah, the area of triangle, let's see. So ABC, the area of triangle ABC is going to be 1. Okay. Okay. BD, sorry, BD, okay, BDC, I'm mistakes here. BC, sorry, BC, not BD. Okay, so I use a comparison. This is a BC, okay, BC, okay, BC. So I find that, but we want to find out the BD, okay, that's a study, okay, BC. So compare those two triangles, be careful. Yeah. So one, BC is a yellow triangle. So it's going twice. And that's going to be 1 times 2, 2 times 1. The reason is this triangle is going to be half of the area of the larger triangle. Okay, then you add them together. Okay, this is going to be 1. The reason is D is the middle point. Okay, since D is the middle point. Okay. And I skip that part while it's here, right? Then you add them together. The triangle BDE is going to be sum of this area, this two areas, right? The triangle BCD plus the area of the triangle BCE. Okay, so it's going to be 1 plus 2, which should be 3. Okay, this is going to be 3. Okay. Okay, 3 is the correct answer. Now I'm going to talk about another comparison theorem. Okay, another comparison theorem. This is in high school math. Okay, we have the following area formula. If this is A, this is a B. That's angle alpha. Okay. So this is A, B, C. Another one will be could be like that. This is also alpha, the same angle, A prime as the B prime. So the area of this triangle, okay, is going to be half of A times B, but there's a number here. Because it's not a right triangle, there's a number called sine alpha. We don't need to understand what is sine alpha. Okay, it's a value depends on size of the angle. And then for the same reason, that's going to be A prime and B prime also the same alpha. Okay, so this is the angle. This is a value depends on the number angle alpha. But in the comparison, yeah, if you look at the ratio, this alpha disappeared. Okay, so it's going to be AB sine alpha, right? Half of A prime and B prime sine alpha. So after simplified, okay, after simplified, you only have the ratio of the products of two sides. Okay. This is a very interesting, this is very interesting result. Okay, so we can use that to solve some other problem using comparison. Okay, okay. Sometimes we have shear angles, right? So here's a typical example. I have a triangle, and the D and the E and the A and the B, C, right? So with DE is a, do we have any conditions? No, it's not necessarily parallel to it's not necessarily parallel to BC. So we have, what we are given? We're given the following information, okay? AD is going to be 3, okay? AE is going to be 4, and the AB is going to be 5, so it's 2 here. So AC is 7, so that's going to be 3, okay? So AD is going to be 3, AE is going to be 4, then DB equals 2, EC equals 3, okay? We want to find out the ratio of the area. It's not necessarily triangle, the ratio of the region at the bottom, okay? So BDEC over the area of the triangle ABC, okay? So when you look at this, okay, DBEC, this is the bottom part. Just we trying to find out the ratio of those two parts, okay? The ratio of the area of those two parts. Okay. How can I do that? Well, these two triangles, they have the same angle, alpha. They share the same angle, alpha. So you can compare the compare those two triangle area, right? So that is going to be, So you can write the triangle ABC over the area of triangle ADE, okay? Okay. No, this is ABC, the small one is the larger one, okay? So ABC and the ADE, I can get this part. Well, I can put it on the top, make it easier, Let me try, I don't want to use let me change this. Okay, the small one is ADE, that's ABC, okay? So this should be equal to 3 times 4, and here 5 times 7, okay? So it's 12, 35. Now, this is not what we want, right? What we want is the numerator is going to be the area of the triangle ABC minus the area of the BDEC, okay? Okay. Okay. Then you can find the ratio of this. Okay. So this is going to be 1 minus something, right? Equals 12 of 13. So this something is going to be 1 minus, not 12, 13, 12, 35. Okay, 12 of 35. So after you do the calculation, this is going to be 23 over 35. Okay, so that is the ratio. Right, let's take a look at the next problem. We have something like that. This is a D and the E. It's a perpendicular. Okay, so we have A, B, and C. We are given AD equals 4, DB equals 4. So it's 4 and 4. Okay, we also given A equals 5. So this side is 5. And we are given EC equals 10. Okay, we want to find the area triangle ABC. Find the area of the triangle ABC. Okay. And maybe even can find the BC, but it's very complicated. BC is determined by an algebra equation. Okay. Yeah, and what is BC? You know, that's just curious, right? I'm just curious. Okay, we can even find the equation for BC. I call it X. Okay. Find this X. Okay, great. All right, so let's do this problem. All right, so to find the area ABC, we just use the comparison, right? So because it shares the same angle at that point, at A, vertex A. So the ABC over the area of the small triangle ADE is going to be the product, the ratio of that product, 8 times 15 over 4 times 5, okay? So that is going to be what? Let's cancel 2, that's 3, so 6. So now you find that the area of the triangle ABC is going to be 6 times the area of the triangle ADE, but the area of the ADE can be calculated quickly. And that is going to be because the other side is 3, DE must be 3. So 6 half of 4 times 3, right? So that's going to be 36. Okay, no problem. Now here comes to the very difficult problem. What is X? Can we determine? Maybe it's an irrational number. Find the equation for the X. Then you can use a computer to solve it, right? That's the inverse problem. Okay. How do you solve this problem? By the Heron's formula, we can determine an equation for X, okay? So let's try, and 4, 4, 15, right? So we have the triangle like that. 15, and here's 8, here's X, okay? So if you know the x, you can find the area, right? So the s, half of the parameter is 8 plus 15 plus x. Okay. So this is going to be right. So now you can get s minus 8. Okay, it's going to be 15 plus x minus 8. S minus 15 is going to be 8 plus x minus 15. Okay, you can do the calculation quickly. Okay, then s minus x is going to be 8 plus 15 minus x. So we can simplify a little bit, and that's going to be half of 20, right? 5 plus 8, 20, yeah, 13. And this is going to be, this is going to be 7. This is going to be x minus 7. Okay, so that is going to be 23 minus x. Okay, not too bad. Okay, so the area of this triangle is going to be square root of s minus 8, s minus 15, s minus x, right? So that's supposed to be equal to 36. Let's square it first. If I square it, it's 1/2 23 minus x, 1/2 7 plus x, 1/2 x minus 7, 1/2 of 23 minus x. So that is supposed to be 36 squared, right? It's not too bad. We can solve it. Okay. How do you solve it? Look at. Okay. This is an algebraic question. Can you solve it? Yes, I can. I can tell you x is a very strange number. So I 4 multiply. Okay. So I take the other side. I have a 23 minus x. 23, 23 minus x, 23 plus x, yeah, 23 plus x, yeah, 23 minus x. So I get 23 squared minus x squared, and I have x minus 7, x plus 7, so it'll be x squared minus 7 squared. 30 squared times 2 times 2 times 2 is 4 squared, right? Yeah. All right. Then how do you solve this equation? Well, this is a polynomial degree 4. Now actually you can do that, okay? So you would get is 23 square x squared, right? Minus x to the 4th power, right? Minus 7 squared, 7 times 23 squared, right? Then plus 7 squared x squared. Yes. Okay. So you will get, I move all the terms to on the left hand side. Yeah, plus 20, let me check, okay? This is a minus positive x squared. Yeah, this is a, yeah, double check, I don't make mistakes. Yeah, the sign is okay. Negative, negative, okay. That's right, negative 7 plus, okay. So 23 squared plus 7 squared x squared, okay, minus 7 squared 23 squared. Okay. So you can solve this equation using the quadratic formula. How do you do that? You move this term to the right hand side, okay? So then becomes 36 squared, 4 squared. This number looks very ugly, okay? But this is a quadratic question, I tell you, okay? If you let u to be x squared, so you get u squared minus some number, right? And that is also x squared become u, right? Then you can find the, yeah, 30 squared, 4 squared plus 7 squared, 23 squared. So the number looks pretty ugly, but you can find the u then you can find x, okay? So there'll be only one solution there, okay? You can find the u, then you can find x, okay? So using quadratic formula, you can find the u, okay? Then you can find the x is the square root u, okay? So that's the idea, sketch the idea. You can determine the third side if you know there's a two sides, okay? If you know there's a two sides, you can determine the third side, okay? Yeah, so if you have a, if you know the triangle, yeah, if you know the area of the triangle and if you know the two sides, you can uniquely determine the other side. Okay, so let's go to another type of problems here. Okay, so we can, I have a triangle. Yeah, let's look at the triangle, okay? This is our typical triangle, 12 and the 5 and the 13. I'm going to draw the line so that this is the same angle, okay? Now, I have a, okay, this is A, B, and C. What I want to find out? I want to find out this side is X, this side Y, this kind of thing, okay? Find X, Y, Z. Okay, step by step. And even can find the area of each triangle. Now, first of all, you make observation. 5 squared plus 12 squared, 13 squared. That implies the angle at the B is going to be 90 degrees. Okay, this is 90 degrees. Okay? Right? It's the Pythagorean theory. Now, what is the next step? How do you use the angle? The same. Well, use the angle. If they have the same angle, then the ratio of the areas, A, B, C, E, okay? A, B, C, let's call D, yeah, A, B, C, D. A, B, D over the area of triangle, okay? And yeah, and this is going to be A, C, D, okay? First of all, okay, this, the user comparison theorem, we have two comparison theorem right now. One is they have the same angle. Use the same angle, that would be the ratio of the product. So 12 times Z, 13 times Z. And actually you only get 12 or 13. Another comparison is just because these two triangles have the same height. So that's why just X over Y. Great. So you have the comparison for X and Y. So you get the first equation, X over Y equals 12 or 13. However, X plus Y equals 5, right? So now you combine those two, you can solve the problem quickly. So you can let X to be 12t, Y to be 13t, okay? Add them together, X plus Y equals 12t, 13t is 25, right? T, 25, yes, 5. So T is going to be 1 over 5. So then you can get X is going to be 12 over 5, Y equals 13 over 5. Okay. Okay. So you find the X and the Y. And how do you find the Z? Because this is a right triangle. So Z is going to be 12 squared plus X squared by the Pythagorean theory, right? 12 squared plus x squared. So that is going to be 12 squared. X is 12 squared over 5 squared, right? Right? And then that's it. You can take the 12, this is z squared, right? Yeah. So take z squared out. It's going to be at 1, right? It's going to be 5 squared plus 1. Okay, I can write as 12 squared over 5 squared and 25, 26. Okay, so you can write down the formula for the z. Okay, so this is how do we solve the problem. Okay, we use a 2. This is a very good example. We use a 2 comparison theorem for this problem. Okay, we use a 2 comparison theorem for this problem. Then you can determine the area of each triangle if you want. Okay. All right, so I'm going to ask you to take a look at the next problem. Right, here's a triangle. We have a triangle A, B, C, and this is an M. Right? So AB is going to be 7, AC is going to be 8, and the BC is going to be 9. Okay? And this angle equals that angle. Okay? So what is the length of the line segment BM? Okay, find the BM. Okay, once you find the BM, you can find the BMC. Okay, so this is just a 7, 8, 9. So this is arbitrary triangle, but this time, this is a line AM bisect this. Right, so please work on this problem. Okay, all right, so what do we get? Okay, this is so Erica, you have a answer. Okay, great. Okay, so the same idea. Let's use X and Y here, right? You compare those two triangles, ABM, the area of the triangle AMC, right? Those two triangles. So first of all, you apply the comparison theorem with the same angle. So this side is Z, right? So that will be 7 times Z and 8 times Z. The ratio of the products are two nearby sides, so it's a 7 over 8. But you can also apply the comparison theorem for the two triangles with the same height, so which is going to be x of y. So you get x over y equals 7 over 8, then we know that x plus y is going to be 9. Okay, so if x plus y equals 9, then you can solve the problem quickly. So you can let x to be 7t, y to be 8t. Okay, add them together. 7 plus 8 is 15, right? 15t equals 9, so t equals 9 over 15. Okay, t equals 9 over 15, and after simplifying, it's going to be 3 over 5, right? Then x equals 7 times 3 over 5, that's 21 over 5, and the y is going to be 8 times 3 over 5, 24 over 5. Okay, 24 over 5. All right, now I want to talk about so-called the middle point formula. The middle point theorem. The middle point theorem says that an arbitrary triangle, we're not able to prove it here, B, and if you can find on the internet, maybe you can find it, okay? So here's a M, this is a N, this is a Q. So M and Q are middle point on each side, okay? Then if we connect them, okay, it's guaranteed that they pass through the same point P, okay? Then AN, BQ, and MC intersect at a common point D. Okay, it's not easy to prove because if two lines, they intersect at point D, but you have to prove that the third line pass through this point. Okay, this is the first fact. Another fact is, this is the first, Second fact is all those six triangles. 6 triangles have the same area. Now this part, maybe we can figure it out why this 6 part have the same area. Okay. Why this 6 part has the same area? But at least you can tell that these two have the same area, right? These two have the same area. These two have the same area. Okay. Yeah, these two have the same area, and the most important thing, you have to compare the other two. So these two, if you can prove these two, then you can prove the rest of it. Okay. Yeah, think about that. How do you shoot? How do you see, right? So we can call this area, let's call the X, X, Y, Y, Z, and the Z. Okay. So YX equal to Y equal to Z. Okay, you have to use other properties. The other property is as follows. You compare these two larger triangles. Let me draw color. You compare this triangle, okay, and with another triangle. Okay, if you compare those two triangles, they should have the same area. So then you get, okay, then Z plus 2X should be equal to Z plus 2Y. So that implies X equals Y. Okay, got it? Yeah, same idea. So that's why all these triangles have the same area. Okay, all the triangles have the same area, so have the same area. Okay. First of all, you compare those two triangles nearby, right? It's two small triangles. So because the n is the middle point, q is the middle point, that's why they should be equal. So you just call them y, x, z, z. Then you have to prove that x equal to y equals to z. Then you have to use the two larger triangles to compare the area, right? So that's called area comparison. I think it's a middle point theorem. It's not a trivial to prove. Right? If you really want to see how to prove it, and then you can maybe search on the internet, find the proof. But the textbook in the United States, they are not require students to prove the theorem. But we should know how to use the theorem to get the results we want. Okay, so we do the computations. Yeah. All right, so we stop here.